All right, so let's talk about linear functions. And linear functions are functions that when you graph them are straight lines, just like it sounds. So let's write that down. Linear function. It's a function whose graph is a non-vertical line. All right. Now this has to be a straight line, but it cannot be a vertical line. Because really quick, a vertical line would be like this. And if you have a vertical line, that means this x coordinate has a y value here, y value here, y value here, a y value here. So you can have one x coordinate having multiple y values. That's not allowed. You can't have this input, which is your x coordinate. This input would have one output, two outputs, three outputs, 4, 5, 6, infinitely many outputs. And that would be really wrong because again, in my analogy, it was this input can only have one output. So this input could only seek one output. And in this case, it'd be seeking infinitely many, which is really, really wrong. Not allowed, not a function. But if it's not completely vertical, then we're good. So, example 1. Write the linear function relating x to y. So I'm going to give you some points that we're putting on a graph. And we'll say it's y-axis and your x-axis. We'll say the first one is 2, 0. And then we'll have 4, 3. And then we'll have 0, negative 3. And lastly, negative 2, negative 6. And we got a line. Oops. And the question is, we have to create the function that relates x to y. Now remember, a function could be a straight line, and a function can also be in the form y equals mx plus b. So it's the equation we're going to use is y equals mx plus b. I see it's a straight line. I know this is the equation for a straight line, so I'm going to go ahead and use that. And that will be our function. So instead of thinking of this as an equation, the new vocabulary word that we use is we call it now a function because it's taking an input and it's giving me an output. So we're thinking of this as our machine, which we call has a function, machine's function. So let's go ahead and figure out what our slope is, and then we'll figure out what our intercept is. So I can already see right here that my intercept is negative 3. And then I can already see that if I have maybe my little vertical and horizontal value there, it'd be 1, 2, 3 up and 2 to the right, which means it would be positive 3/2. So your slope, your vertical change and your horizontal change. And now our whole equation would be y equals 3/2 x. Now instead of putting two symbols, we're just going to leave this as a subtraction. And that is my function that relates my x to my y. It tells me what's happening to x. It's getting multiplied by 3/2, it's being subtracted by 3, and the result is y. Next one, example 2. Write the linear function using the table. So here's your table. It's a table of values. -3, -2, -1, and 0. That's 9, 7, 5, and 3. So, because it's a linear function, remember, is going to be an equation, and it's a straight line. So what do we know is the equation of a straight line? Y equals mx plus b. This time I'm leaving open boxes. Remind myself I'm trying to plug in my m and plug in my b. So how do I get m? I don't have a visual, but all I have is points. And if you remember, there is a slope formula, and I used to call it the skeleton because I like to write the structure of it before I plug in the numbers. So let's say we're looking for a slope. That's my skeleton, that's my formula without the numbers, or without the meat, I like to call it. And I only need 2 points. I have 4. This table gives me 4 points. So I'm just gonna pick 2. And I'm just gonna use the first 2. So -3, 9 would be my first one. And -2, 7 would be my second point. I'm gonna use those in my formula. So again, my vertical changes on the numerator. Vertical is my y coordinates. So it'd be 9 minus 7. And then my horizontal is my x coordinates, -3 and -2. It's really important to write the structure of the formula first because it won't confuse you when you have a negative and you already have a subtraction. It just makes things cleaner and neater. And so when you subtract on the top numerator, you get 2. The bottom, when you add the opposite, you get -3 plus 2 is -1. And I know that 2 divided by -1 gives me -2. So my slope is going to be -2. And now I'm going to find my intercept. Remember, when you have an y-intercept, any point on the y-axis is going to be 0, comma, some number. So anytime you see your x-coordinate of 0, you know you're on the y-axis. So over here, I see that. So my y-intercept must be 3. And there you go. That's your equation. Y equals -2x plus 3. All right. So the next example. Now we're going to apply real-world examples and see if we can analyze how the structure in the equation relates to the real-world application. Earnings Y and earnings is how much you make of an employee that's working X hours is represented by the function y equals 7.5x plus 30. What is his hourly wage? So if the earnings are y and your hours are x, this equation says y equals 7.5x plus 30. So y means this is what we're going to be making. The money we're making is going to be equal to 7.5 times the hours, because they're telling us it's x hours, plus 30. Let's think about that. If the amount that you make is equal to 7.5 times the hours that you work plus 30, how much do you make an hour? So if you were thinking $7.50, that is the answer. I just put the 0 because I know that it's representing money. So $7.50 would just mean $7.50. Now, how did I know that? Because I know that the rate is always the slope. A slope is a rate. And then I got x representing hours. So this must be the rate per hour for every hour, $7.50. And because I noticed that there's a variable here, this rate is getting multiplied over and over and over again for the number of hours being worked. So $7.50 for 1 hour. And then if he works 2 hours, that's why I'm multiplying it by the number of hours there. So that's where you would find the rate of dollars per hour. On a graph, it actually would be your slope. So let's look at another example. So we can identify and relate these things to the real world. Makes it easier. Example 4. A worker's earnings is represented by the table below. And here's your table. Hours, X, and the amount of money, pay, Y. So if you work for 1 hour, $12.50. And if it's 2 hours, it's 25. That's 3 hours, it's $37.50. And if it's 4 hours, it's 50. So what is the hourly wage? So again, in the real world, this is how it would be applied. So looking at the data, where would you know, or what would be the answer to how much this person makes in 1 hour? Hourly wage, which key word is hourly. We're looking for the unit rate. So right here shows us for 1 hour of work, you get paid $12.50. So that would be our hourly wage. So you would write down $12.50 for each hour. And on the graph, that would actually be your slope. $12.50 for every hour. $12.50 another hour. $12.50 another hour. So it would actually be the slope on the graph, it's your unit rate, and it's your constant of proportionality, because it's the amount that's constantly being used to keep that proportion. This person is getting the same rate every hour. All right, there you go.